welcome back. Today is day 25 of this 30 days Leetcode challenge, and today's question is jump game. So let's get started. We are given an array of non-negative numbers, non-negative integers, and you are initially positioned at the first index of the array. So we start off at index 0 of the array, and each element in the array represents your maximum jump length at that position. So our the value at a particular index represents the maximum jump you can make from that position, and we have to determine that if we can reach the last index of the array or not. So let me try to explain using this example. So this is the array that we are given, and we start off from index 0. So at index 0, the value is 2. So the maximum jump we can make will be of length 2. So we can either make a jump of length 1, or we can make a jump of length 2. Now, if we make a jump of length 1, we end up at 3, the index 1. So now we have three possible options. We can make a jump of length 1, or of length 2, or of length 3. Now if you observe, if we make a jump of length 3, then we can successfully reach the last index. So in this case, there is a possible path in which you can reach the last index of the array. So the output in this case is supposed to be true. Now, similarly, if you explode this example, now the element at index 0 is of 3. So we can make jumps of length 1, 2, and 3. Now, if we make a jump of length 1, then we end up at index 1, which has a value of 2. So from here, we can make a jump of length 2. So if we make a jump of length 2 or 1, we end up at eventually end up at this value uh, at index 3, which has a value of 0. Now from 0, there is no possible jump that we can make to reach the last index of the array. So in this case, there is no possible path. So in this case, we have to return false. Now, if you observe this question and try to implement it the way it has been explained, you'll realize the time complexity for running this algorithm ends up as an exponential, ends up in exponential times, because every time you'll be trying for all possible paths from a particular index, and recursively you'll be end up trying the same thing for the final for the next index as well. So you'll be trying for the same for multiple paths from the same index. So also, if you observe that once you reach a failure point, uh, and if you do not use memoization, then for a different path, if you reach the same failure point, you'll end up calculating all possible paths from that point as well. So there is memoization also can be used in this case. So however, what I'm going to do is I won't be using memoization. I'll be using the concept of valid positions and invalid position. So in the array, those indexes from which I can reach the last element of the array, I'll mark them as valid indexes, valid positions, whereas those positions from which I cannot reach the last index, uh, I'll be marking them as invalid positions. So I will be using a Boolean array, and initially I'll assume that all the possible positions are invalid, and I'll start iterating from the last index and reach up to the first index. And if I end up with in my final result with the first index as positive as a valid position, then that simply means that uh, there is a possible path from index 0, which I can use to reach the last element of the array. So I'll, let's start implementing this. So I'll use a Boolean array, which I'll call this as valid positions, and this will be of the same length as the length of the array, the input array that is passed to us, and I'll mark the last position which is nums.length minus 1 as a valid position. And now for all the elements starting from the last element, from the second last element, I'll iterate through all the elements up to 0 and decrease I at each iteration. And now I'll start a j which will run from 0 up to the value of the nums of I. So j has to be less than equal to nums of I. So I'll be trying for all possible combinations, but while trying I have to also ensure that my I plus j does not go out of the bounds of the length of bounds of the input array that is given to me, and every time I'll be incrementing j. Now in this case, all I have to do is check whether the valid position for I plus j is already marked. Then I can say that there is a possible path starting from index I uh, that will take me to and the valid position, which will eventually take me to the last index. So, and at the end, I just have to check whether the valid whether the index 0 has been marked as a valid position or not. So uh, and once I find a valid position, I have to break it out of the loop. So I don't have to try it for all possible positions. Once if I find even a single position, that should be enough. So if I run this check code and check valid position of I. Okay, I have to mark this as true. Sorry. So if I run this, yeah, so it works for possible path. Let's say, let's try it for another input, which was 32104. So for this, we should get the output as false. Yeah. So if we submit this solution, you'll see that it has been accepted, and but if you check the runtime, you'll observe that it is pretty slow. If you actually check the code, you are doing the iteration twice. So for every possible I, you are checking for all the elements that are to the right of I. So basically our code runs in log of in n square time complexity. Now, if you actually check, we are breaking out of the loop as soon as we find a first occurrence, first valid point. So all we have to do is check from I up to I I to I plus nums of I. If there is a valid position in the range from I to I plus nums of I, then we can say that 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 is a possible path starting from index I. So we don't have to store all the valid positions. We just have to check what is the last position, last valid position, and if that is within the range of I, then our index I will become a valid position. So so that is what I'll try to implement, and we can do this in linear time complexity. So that is going to be my second solution for this. So what I'll do is last position, and I'll say that nums of length minus 1 was the last valid position, and then I'll iterate from nums of length minus 2, the second last element, and I'll keep going until index 0 and decrement it. And then I'll check if I plus nums of I, if this value ends up becoming greater than or equal to the last position, last valid position, then I'll just update my last valid position to I. And at the end, I just have to check whether the last position that was obtained was 0 or not. So if you check, this algorithm runs in linear time complexity. There is only one for loop involved. And let's run this and check. So it works. So if I submit this, uh, yeah, so our solution is accepted, and If you check the runtime is in 98.65%, so it is a pretty good runtime. So that's it, guys. So if you like this video, give it a thumbs up, and do subscribe to my channel to be notified about day 26 problem. We are almost reaching out to the last 30 days challenge. So only 5 days are left. So thank you, guys.